From Meta, please welcome Omar Baldonado.
Hi, everyone. Probably like everyone else today, you feel so excited, and I'm no different. I'm so excited to be here. My name is Omar. I'm part of the Meta Network Infrastructure Group, and I'm also one of the co-leads of the OCP networking project, and have been doing that almost since the beginning. So to start off, just wanted to also recognize the happy 10 years for OCP. It is amazing, Bill and Rebecca have covered all of this journey that we've been in over the last 10 years, right? The concepts of open source that were in the software community, how do we bring that to the hardware community? And it's really blossomed to what we have now today, this We Are OCP, as Arshana was saying, that we have today. Now, over the last 10 years, there's also been a lot of change and a lot of growth at Meta. The family of applications, Facebook, Instagram, WhatsApp, Messenger, billions of people using these services and relying upon them every day. A whole set of other products and features. And then the future initiatives that we look at, connectivity, AI, and AR/VR. And I'll be talking more about that later. Now, the history of Meta as relates to OCP, they've really been intertwined. We have a history of openness and innovation. Specifically, if we look at networking, you can see there are a few components I'll go over. There's the hardware that we've been contributing, there's the software that we work on, and then the topologies and networks that come together. And it's all in this context of disaggregated open networking. So let's go into a little bit of detail, just to look back at that 10 years. So these are the contributions that Meta has made over the last 8 to 10 years, really throughout the history of OCP networking, starting with the Wedge 40, our first switch that we built in a disaggregated way with the community, all the way to a couple of years ago where we announced our Fabric Switch mini pack. Then if we look at the software, we have a unified software layer on top, FBOSS, that works on all of those switches. We've contributed key parts of that to open source. And that is also key for us, open in the hardware, open in the software, such that we can work with all of you, with vendors as well as other operators like Microsoft on building this software community. And then, conveniently lined up with the last 10 years, the 10 years of our topologies, of our networks, starting from smaller cluster designs all the way to the fabric design and the largest network design that we announced a couple of years ago, F16 and HGrid. So all of these together kind of are a retrospective on the last 10 years. But now let's focus on the last couple of years, right? It's been a while since we've been on stage. It's been a while since we've been able to contribute at large, with all of you. And amazingly, we've been busy. We've been busy over these last couple of years under some very trying and challenging circumstances, but I'm really excited to share all of these today. So the first thing I wanted to cover was something we actually introduced earlier in the year. Meta worked on the time appliance project with OCP, and kicking that off with designs for our time card and our time server in order to support the precision timing that our services need. We've also been active in the space of optics, key for that interconnect. 200G we contributed last year, our own particular variant with our restrictions and constraints that work at our scale. We're going to share some of those deployment learnings today. And then today we're also sharing that we've been developing the 400G variant in order to keep up with all the speeds and workloads that we have in the data center. I wanted to call out also one of the partners that's been working really well with us and within OCP, Innolight, which has contributed a lot of these products in the OCP marketplace so that they're available to everybody, so that you can use the same technologies that we've been developing. So for the next set of contributions, let's go back to this fabric, right? Let's go back to the network. So at the core of this network are fabric switches. Every one of those dots up there is a fabric switch. And we've been working on the next generation of those fabric switches. In particular, with the next partner we'll bring up, Arista Networks has been working on this. So please help me welcome the Chief Operating Officer of Arista, Anshul Sadana. Hey Anshul, welcome. Welcome. Excited to jointly announce with Arista today our, your switch that we've been developing, the next generation fabric switch. Maybe you can take a few moments, just share what that partnership has been like with Meta. This is our second switch together.
Absolutely. Thank you, Omar, and great to be here. As you mentioned, we've been partnered for 10 years with Facebook, now known Meta, and this is the second time we've done a co-development project. The first one, about 3 years ago with Tomahawk 3, was making it OCP compliant in terms of serviceability. A big achievement was being able to replace the switch card without having to touch a single fiber cable, which saves a lot of time in the data center. But if you look at the next switch that we've been working on, this is the Arista 7388. We've spent about 2 years working with the Meta team together. And when you work in these co-development environments, there's a lot of trade-offs engineers have to make. What's great about this partnership is we're able to sit down and have those trade-offs for some key achievements. I'll give you 1 or 2 highlights about this product. When you look at networking, one of the biggest challenges facing us today is as bandwidth increases, how do you contain power consumption? Because if switches get more and more power hungry, they break the allocation you have today for networking. And we managed to work together, some great innovation, and the product here has been designed without any gearboxes, despite all the breakouts and so on. So this saves a good, almost 20% of the power is saved in this design. And on top of that, the same modules can support 200 gig or 400 gig, again, without requiring any gearboxes. So I think that was really, really cool for the teams to come together and make it happen.
Yeah. No, it's been great working on this over the last few years. Even before our last announcement, we had already started working on this together. So can you maybe share some thoughts about working with the community as a whole, like within OCP, to develop this together?
Absolutely. We first started this along with the Meta team 3-4 years ago on the Tomahawk 3 product. And today, there are over 100 customers who have deployed the same product in their data centers. Our switches support both AOS and FBOSS, so it continues the journey of disaggregation, but also allows many enterprises and smaller cloud companies to adopt the same technology in their data centers as well.
Yeah, that's a great thing for us to see, to bring that technology, as Rebecca was saying, bring this out to the community as a whole. So thank you very much, and we look forward, thanks to you and your team, because I think our team, we've been working hundreds of engineers together, and looking forward to the partnership in the years to come.
Great, thank you so much.
Thanks, Anshul. Anshul from Arista. So let's go a little bit deeper now, right? So we partner with other companies in the ecosystem, like Arista, to design and develop the switches. But if we go a little bit deeper, what's at the core of those are the ASICs. Right? So at the ASIC level, we have 2 new contributions, 2 new switches that Meta has designed, also based on the Broadcom ASICs. We have the Meta Mini Pack 2 fabric switch, much like the Arista switch based on Tomahawk 4. And then we also have our new top-of-rack switch, the Wedge 400, based upon Tomahawk 3. These are Broadcom ASICs that we're building on, and I'm excited to also announce, not only do they run FBOSS, but now our whole fleet of Broadcom-powered switches now leverages the OCP project, the Switch Abstraction Interface, the SI project. So that's now widely used by us, and a testament to the power of the community that we're able to leverage that. So to help me go over the Broadcom contributions with us, please help me welcome Senior VP GM from Broadcom, Ram Valaga. Hey, good to see you.
Good to see you.
So Ram, if we take a look at this, we've had a long history together, really since the beginning of OCP networking, and Broadcom has been such a key partner in providing that disaggregated open networking for us. Maybe you can just share your thoughts on this history that we've taken together over the last few years, and then the latest chips that we've been using from Broadcom.
Oh yeah, great. Thank you, Omar. So 10 years, right? So 2012 to 2022. I would say in silicon, how many silicon years is that?
That's a good way to think.
It's 5 years, 5 silicon years, right? Every 2 years or so, you have another chip that comes out. So if you look at this period, in 2012, Trident 2 was probably the fastest chip on the market, which was 128 ports of 10 gigabit Ethernet. And over this 10-year period, we've gone from Trident 2 to Tomahawk 1, Tomahawk 2, Tomahawk 3 to now Tomahawk 4, which is at 25 terabits per second. That is 256, 100 gigabits, right? And so over this period, what we've really done is scale the bandwidth about 25 times, but more importantly, really be able to deliver a power per port or power per gigabit that's about 90% less than what we had in 2012, right? And working together, what we've also been able to do is having a very predictable execution cadence, because when you're actually working with a very large open community, they put in a lot of their R&D around what they expect the availability of your product and your silicon. And that cadence of execution, when you're able to execute and they're able to line up around it, it makes it so much more easier to bring things to the market. And the other thing that we've done, obviously working with the Meta team, is you have pushed us very, very hard. I remember about 4 years ago telling us, hey, look, every watt of power taken off your switch is X number of cars taken off the road, and you guys have to do something about this power, right? And we've taken that very, very seriously. And every successive generation of the chip, we make sure we are removing features rather than adding features. And we will continue on that trend going forward too.
Yeah, no, you've been a great partner thinking about that, just looking at this 90% reduction in power. The speeds and the feeds, which are good, which we absolutely need, but then also being more efficient, being more sustainable, really important for us. Maybe you can talk also a little bit on the last few years we've been focusing on the software layer too, in terms of how we program and access the features of your ASIC, and specifically the switch abstraction interface, SI. Can you talk about how that partnership and your dedication to that over the last couple of years?
Yeah, absolutely. Look, I think while we come out with silicon, here's an example of an Tomahawk 4 that's 25 terabit. This is actually based on Meta's feedback. You guys came and said, hey, we need to have 50 gig SerDes on this and not 100 gig SerDes. We obviously had another version of this chip with the 100 gig SerDes, because no two web scalers are the same in terms of your requirements. While you all think you're on 25 terabit, everybody has a slightly different manifestation of this. So what happens is when you have so many of these chips, the consumption of these chips could be tough, because you have to integrate your software on top of the silicon. So really what we have to start focusing on is how do we make the consumption of these chips far more easier. And right now we have our SDK. About half of our team is actually focused on developing the software layer, which is the SDK. But that is not sufficient, because there's a lot of APIs which are not necessarily open to everybody. And Meta's feedback to us many years ago was, hey, can you actually help us accelerate the adoption of the silicon? And Meta, Microsoft, and the others have worked to pushing towards SI, which is the software abstraction layer. And actually working very closely with Omar's team over the last year and a half, we were able to get out a series of switches supported on SI, actually making that SI also available to the broader community. And making sure that going forward, when we come out with new chips, along with our SDK, we would also have SI available, so that for those who are developing on SI, you will be able to come out with the products about the same time that you can come out with products with the SDK too.
Yeah, that's been we talk about disaggregation and the importance at the hardware layer, innovation there, but also innovation at the software layer. So I really wanted to thank you and the team for the partnership, not just on these switches, but also the partnership over these years, multiple generations. That everyone can see. The OCP networking and the OCP community in general is thankful. Again, we're looking forward to the next 10 years.
Thank you. We're very thankful.
Thank you very much.
Take care.
Thanks.
Bye.
Okay. Ram from Broadcom. All right, so you can see the history there in terms of in the dedication toward open networking and disaggregated networking that we've had with our partners. But the community continues to grow, it continues to expand. And for this last announcement of our contribution, I'm excited to welcome our newest partner to open and disaggregated networking. We now have the Wedge 400C, which is our first contribution built with the Cisco Silicon One chip. And to help me go over that, please welcome Rakesh Chopra, fellow from Cisco. Hey.
Hey, Omar.
Good to see you, Rakesh.
You too.
Thank you for coming and talking. You know, this is exciting for us. You know, our newest partner at the ASIC level and working within the OCP community. Maybe you can talk a little bit about how was that for you and the team developing this in a disaggregated way.
Sure, fantastic. So first of all, I wanted to thank Omar, you and the entire Meta team for having us here today. And I think most importantly for trusting us in our sort of commitment to this environment. So for us, I think, you know, really this started back for us about 7 years ago. We started off a series of investments where we invested about $1 billion. And we sort of removed the covers and brought it to the world in December of 2019, when we actually did a big launch inside of Cisco called the Internet of the Future, where we announced the Cisco 8000 iOS XR7. But I think for this community, the most important pieces are the fact that we announced Cisco Silicon One, as well as sort of a disaggregated business model. And so all of a sudden now our customers had a choice in how they consumed our technology. They could obviously still buy full systems from us, but if they wanted to buy just the silicon, that's great too. Like, we're open to any of those type of engagements. Now, you know, since then, of course, we haven't been standing still. Over the last 22 months, we've released 11 chips in the Silicon One family, spanning all the way from sort of web scale top of rack switch, all the way to service provider aggregation and everything in between. But, you know, I think, to be honest, I think many people actually didn't believe us that we were serious about going down this disaggregated path. And so to me, that's actually what really brings us to today.
You know, so it is a journey, and I'm glad we've now started and made this significant contribution, the Wedge 400C. Maybe you can talk a little bit about the chip and then also the software interfaces on top that we asked you to support, you know, again, working with Sai.
Sure, fantastic. So I think, you know, today we're excited to jointly announce with Meta and Celestica the sort of mass production and deployment of Wedge 400C. So this is based on the Cisco Silicon One Q200L device. It's a 7 nanometer, 12.8 terabit run to completion P4 programmable switch. And, you know, I think going into this environment, I have to admit, I wasn't really sure how all the teams would gel together. Right, we've got teams in multiple different geographies, different time zones, and different sort of cultures. And actually what was amazing to me was actually how, when all of these teams came together, all the traditional walls that you see between big companies disappeared. And the teams really sort of worked together as one virtual team, really sort of trying to focus on solving Meta's hyperscale problems. The other sort of big takeaway I had in this environment was, at the end of the day, what ends up happening when you build a piece of hardware with Cisco Silicon One Q200 around it. We layer our SDK, then we layer our SAI abstraction layers on top of it, and then you port FBOSS on top of the SAI abstraction layers. Right, I think you heard it before, but at the end of the day, right, SAI is a great way to allow various different OSs to port on top of different silicon substrates. And I think this entire engagement to me is sort of a testament to what happens when companies work together in an open forum, whether that's open source or open-mindedness or in OCP. To me, it's just a great engagement that we've had with Meta, so we thank you for that.
Well, we thank you, and we're looking forward, definitely. This is the first joint announcement for us, but I'm certain it won't be the last.
I'm looking forward to the future. Thank you very much.
Thank you.
Take care.
All right.
Bye-bye.
Cash from Cisco. So just to wrap up here, right? So if we look back, these were the contributions up until, you know, through the history of OCP networking that we've made. We're contributing all of these now today and sharing that with the whole community. There's a whole set of teams that have been working together inside Meta, the FBOSS team, the network hardware team, data center network engineering, sourcing, project management, too many to list here, and then all the partner teams at all our other companies. We are all OCP working on this together. And you can find out more from those teams, a lot of workshop talks from Meta and from our partners over the next, this afternoon and tomorrow. So just to wrap up, what are some of the challenges that Meta faces and that we see going forward in the community that we want to work on with you? First, we're going to continue designing the hardware and the software and the overall system in a co-designed way. This co-design where we really work on the system together, as thinking of it as a whole, is a trend that we've been talking about, and it's definitely going to continue. AI as a workload, critical for us, and really highlighting the need for this co-design. If you go to the exec track later today, a couple of our colleagues from Meta, Whitney and Divatsa, will cover how we've been designing our latest AI training clusters, and the core of those, the Xeon EX platform. You've heard recently, of course, Meta. Mark has covered that vision, Meta and the metaverse. It's an ambitious vision from a technology and infrastructure perspective. It's pretty daunting just to figure out how we're all going to do this together. I don't know how it's going to work, but we've got another 10 years to build on that and work on those things together. And then to wrap up, something that many of us have already covered, and we're always thinking about it, power efficiency. We have the responsibility to be sustainable. We have the responsibility to do all this design and innovation and do it in a way that is caring of the environment, caring of our world. Sustainability, circularity, these are all things that we have to keep in mind as we innovate and design together. So thank you very much. This journey is 1% finished, something that we've always said at Meta, and I'm really looking forward to the next couple of days of just connecting with all of you, sharing, and hearing more about how we want to tackle all of this together. Thank you very much. Enjoy the rest of the day.